When I started to write this presentation or think about it, I thought that this will be like technical tidbits about how to port from Python 2 to Python 3 and don't do this, do that. I found out that this is mostly useless because if you put Python 2, Python 3 porting to Google, you get zillion of pages which are describing most of it. And the second, I started to be interested in the other question. There are many projects on the internet and in the free and open source world which are sometimes quite important for some people and which are abandoned, dead, or severely unmaintained. Do you know the term bus factor? How many people would it take to fall under the bus for a project to die? And it is shocking how many projects which we rely every day and which are crucially important for the whole Linux or free software world have bus factor 1. We saw last year or year before the last year how few people are working even on OpenSSL. Like whole world work runs on OpenSSL and it's like 5 people if they are working together. And most of them are not doing it even full time. So there are many projects. If you are in the previous person was talking about how to start your career in with Python. The next step is you have some really crappy programming or system administration or something which is closely related to IT, but you want to get the real programming job. And the best way how to get, I was in Red Hat for 11 years, so I know a little bit how to find a job in a company like that. The best way how to get there is if you are maintainer of a big successful project. You say, I am the maintainer of util Linux NG, and it is not about you are asking for a job, they are asking you to work for them. So one of the ways how to get your foot into the doors is to find a project and to maintain it and to be known for that. Good news is there are many projects on the internet which are, as I said, dead, unmaintained, and some of them are really important, some of them are really something which a lot of people depend on, and there is nobody who cares about it. So this pulling dead projects out of their graves, it looks kind of zombie-like, but some of it is really useful. So I've pulled out a couple of these out of their graves, and the last one which got stuck with me was M2Crypto. M2Crypto is the remainder of the failed project Chandler. That was an attempt to write then something like Outlook, but it was supposed to be free software, it was supposed to be multi-platform, it was supposed to be independent on any server, so it would just, you have your own data and you share your data. It never really worked, it never really fulfilled those promises. But one thing which fell out of it was M2Crypto, because they made even their OpenSSL bindings for Python. Project Chandler collapsed in 2009 when the original funding ran out of it. They had some more money, so they were able to employ one more guy to maintain just M2Crypto for 2 more years. But since 2011, the project was basically abandoned. Now even the original website where the project was is gone. So unfortunately for me, for example, our Bugzilla with all bugs is gone as well. So I don't have access to the original bugs, but that's how it works. The only real maintenance was that the package was part of Red Hat Enterprise Linux. So we, well, I'm still saying we, people in Red Hat had to maintain it, and there was a good guy, Miloslav Trmac, who was basically the only person who made some patches when we got the bugs for M2Crypto. But those patches were just stacked in the packaging repository, and nobody knew about them. And there was never any issue tracker and all this stuff you need for the project to be working. So in 2015, as I said, I have my lust for that project. So I pick up this one, and I thought that I will just put the history on the web. I will put all those, I don't know, 10 or how many patches on the top of it, and that will be done. What I didn't know is that actually there were many people who were using the project, but they were inside of the companies. It was used for the inside projects quite a lot. And they didn't know where to turn for any support, so they didn't do anything. But when I put out the project on, originally it was Gitorious, that collapsed as well, so I moved to GitLab. Now I'm happily on GitLab. They suddenly went out of their sheds with all their patches and complaints, and I suddenly found out that this is actually project which would require a lot of work, and that I need to, and that's the thing I would like to talk about. There is that moment when you pull out that project out of its grave, and you find out that actually there is a lot of life in it, and that it will require a lot of work for you. And that's the point where you should sit down and make, in a business world, it's called SWOT analysis. Analysis of the strengths, weaknesses, opportunities, and threats. So you should sit down and think about why are you doing it? Does it make any sense? So what are the strengths of the project M2Crypto when I started? Well, it's actually pretty well working. It's backed by very stable, very mature, very well beaten C library, OpenSSL, which is probably most widely used encryption library, free software encryption library. It is actually one of the most, the Python bindings is the widest coverage of the OpenSSL. So if you want to use it for some really weird stuff, if you want SSL just to make a HTTPS connection, you don't need any special library. It is part of the standard Python, and don't bother with anything. But if you want to work with certificates, if you want RSA, if you want some really SMIME, some weird stuff, you need some special library. Well, M2Crypto has probably the widest coverage of these weird things. As I said, suddenly one of the nice things about the pulling that projects out of their grave is that you get a lot of the stuff for free. What you get for free is actually user community. There are many projects you start on the green field, and you are like trying to get some attention. Here you have attention already. You have people who actually know what it is about. And yeah, technically, nice thing about it is that it was developed professionally, so they know that they need tests, so that there is quite nice test suite. The weaknesses, that's the other part. Well, you can come to the project and you don't know, A, you really don't understand the code, because this is a huge project and you have to find out what's going on. But B, you really don't know what are the problems of the code. Perhaps you will start to maintain the project and you will find out that you are in the, until your neck in unresolvable issues. The second problem is that actually M2Crypto API is really close to basically mapping the OpenSSL API, and I have to admit there are better APIs in the world than the OpenSSL, so it's really easy to shoot yourself in your foot and to write something insecure with it. So that's a problem. And yes, it was because it was maintained basically only in Red Hat, it really didn't work. They promised that it should work on Mac or Windows, but it really didn't. So what are the opportunities? Opportunities are that you have the current user base and you can just react to their issues. You can, there is opportunity to replace PyCrypto, and I don't want to get that would be a long rant about why I hate PyCrypto. So sometime later, you can ask me after the presentation. One of the things, if you are working towards legacy users, if you want to support already existing user base, we need to keep API stable, like rigorously, no question about that. So no creativity in API. And of course, one opportunity is that if we extend the support for non-Linux platforms, we can dramatically increase our user base. Threats, well, one threat is that finally Python SSL module will, meaning the SSL module in the standard library will get so good that nobody will need a third-party library. I don't think that will happen anytime soon. And that's, there is actually a competing project called Python cryptography, which tries to do basically the same what M2Crypto does, but they have certainly better API for on the Python side, and they originally promised way better treatment of different the SSL engines they would like to work with. Everything else, it basically collapsed. They are now the same. They work on OpenSSL, but perhaps they will be better and more widespread use. So the second, so you make this analysis and you said, okay, let's go ahead. We want to make, I want to maintain the program. I want to be the leader, stick my flag in the ground, and to keep the project going on. Well, the biggest problem, I didn't say it as a threat, is that, of course, M2Crypto being from 2010 is Python 2 only. Python 2 only projects are doomed to die in a year and a half, so it's crucially required that it needs to be ported to Python 3, which gets to the second part of my speech about porting to Python 3.
It's actually a misconception that they will die in a year and a half. They actually not die there, but it's just about security.
Well, I can I think they will die, but we can talk about it a little later. Because M2Crypto is binding to C library, of course there is a part which is in C and there is part which is in Python. So, and you have to port both of these because the C part uses the Python C API, which has changed as drastically as the Python part changed. So you need to port both of these. Of course, the second part you need to do is to actually understand what the project is about, because there is a lot of stuff which you don't understand when you start originally. I found it really useful to have CI. When I want to support, when I'm relying on my test suite And when I'm trying to make supporting more platforms than just Linux I have on my computer, I crucially need CI to be able to run on everything else. I tried to play with Travis. That's what you have per default on GitHub, or which is linked to GitHub. I've never understand what's the relationship between Travis and GitHub. And I found it lacking. Their versions of Python are weird, and their versions of OpenSSL are even more weird. So to get like if you want to test on multiple platforms, multiple versions of some crucial library, you probably need something more flexible. I found there were much better experience with GitLab CI, where you can have your own Docker image. You can run basically anything with any version of anything. Basically, if it is on Docker Hub, you can use it. And I had better experience with that. Okay, now a couple of tips. One thing, of course, sorry, a couple of tips now. So, of course, porting from Python 2 to Python 3, the biggest issue are strings. And that str in Python 2 means basically anything. It means from a random bunch of bytes to real text, and you cannot distinguish it. In Python 3, you have to distinguish it, and it's very useful. Actually, in Python 2, you can use strings even for things which are very well structured, but it's just a bunch of bytes which you throw into the str object, and it works pretty well too. So this separation of str into the 2 or more types in Python 3 is probably the biggest deal of everything. The second problem I had with while doing it, that in the middle of my porting, when I was kind of trying to be Python 2, Python 3 compatible, I found out that OpenSSL released a new version 1.1, which is incompatible with 1.0, because they decided finally that they will get new shiny API with getters, setters. You are not using just pointers, which is lovely, nice. It's a good idea, but that means that I have to support two APIs at once. My first effort was what was probably most intuitive. So you use ifdefs. Ifdef Python 2, then you do this. Ifdef Python 3, you do that. Ifdef this version of OpenSSL, you do this. And the result was complete junk. The code which was so ugly that I didn't want to touch it with a 10-foot pole. When I was almost done with this project, and it was so ugly that I decided that I will completely rewrite it to something better. And after investigation, I found out that the way better way is to use shims, meaning you are writing against one API. So, for example, OpenSSL 1.1, which is more civilized API. And if there are some functions which are missing in the 1.0 API, you just write your own implementations and use them when necessary. The same goes with Python 2, Python 3. You write, I thought that I will write to Python 3 only, and whatever is missing from Python 2, I will use my own replacements. It didn't work that way completely, but mostly. Yes. So that's basically what I am saying, that there are some examples. So Python 2 doesn't have pylong from long, Unicode as UTF-8. So I made my own versions and used them. I found that actually there is support for bytes objects and text objects in deep hidden in the Python 2 since Python 2.6 on the C level, so you can use it and you don't have to write your own versions of that. On the other hand, for example, in Python 3, there were some very useful functions which I used in Python 2, and they are gone from Python 3. I don't know why. PyFile as file is basically, you put there, on the input you have Python file object, and it returns the file in all capitals from glibc, which is a very useful thing to have. I don't know why it got removed from Python 3. Yeah. Yeah. Well, actually, there is file object underneath the IO object, so. But yeah, when you need it, it would be lovely if you could get there. I had to write my own version, so it is possible, but yeah. One thing which is rather controversial are type hints. Many people use Python just because they hate strict typing and static typing, and they run out from Java, C++, Word, so that they don't have to bother about types, and now they are pushing types on them again. So my experience is, it is really optional, so if you don't want it, you can ignore it most of the time. And the second, I found it really useful when you are working with libraries, because when you have library and you want to have some API, it's the best way how to actually define that API and to be sure that you can understand it. Same when you are in the process of having basically undocumented, a lot of undocumented code. This is one way of documenting it, which is quite useful. And contrary to the expectations, type hints came natively to Python in 3.5. And if you write it as it is in 3.5, it is syntax error in Python 2. So there is a way how to do it with these commands, which is supported by all tools which are supporting type hints. And it's just a command, so it works in Python 2 perfectly well as well. So highly suggested, good thing to make order in the world. Yeah, this is just the same about on the Python level. Again, shims not if devs. 6 is great, use it, or even better are those two later ones. 6 is more like how to write Python 2 code in Python 3. These two are the other way around, which is probably better, but they were not available, or I didn't know about them when I started. So I'm using 6, but yeah. And actually, only when I was writing this presentation, I found out about this page. If you are in the need of porting from Python to Python 3, this is a really well-written list of hints and advices how to do things in a compatible way. I really liked it. Yeah, so this is the site, official site of the M2Crypto. This is my email, and I am on GitHub, GitLab, Twitter, Freenode, anywhere I'm on as MCEPL. Questions?
So the applause. Thank you very much. Can you hear me? Good. So the first question from Slido is, did you consider rewriting only the M2Crypto API on the top of cryptography instead? Do you think that would have been easier or harder? Sorry.
I did consider it, and I tried to do it, and I found it a waste of time. M2Crypto does exist, it works, and I don't have anything about cryptography. I think it has better API, the Python API than M2Crypto. If I was starting a new project, I would probably prefer cryptography to M2Crypto. But if my main task is to support current user base, I really don't see the need to rewrite. It will be a lot of work, which is, in the end, would be useless for my users.
Okay, thank you. Do we have some more questions from the crowd? Yes?
Yep.
Just wait for the mic.
The question is on the Python to C binding.
Yeah.
You said you used Swig, but
Yeah.
at the same time you're using the C API of Python.
Well, Swig is not magic. Swig will help you to make you see interfaces to the C objects in the OpenSSL, but there is still a lot of code you need to write to make the logic working together. Swig doesn't do everything for you. It helps a lot, but you cannot replace. You have to write C still.
So the second part of the question was, have you compared to other tools like Cython or CFFI,
Again,
Boost Python?
If I was starting from scratch, I would probably do something else than Swig. I like Cython. Cython is really nice. Or perhaps CFFI, so you don't have to write C at all. But again, the same question, why not to write on the top of cryptography? I already have a working code, and it was way easier to support what I have done to rewrite it.
Okay, thank you.